are drawn with triangles and T-squares so that they're precise. There's our truth. Everyone with me so far? Okay. Yeah, we're gonna make this one. The horizon line. Everyone good on the horizon line? Everyone knows how I got it? It's how where my eye is above the ground plane, parallel to the ground plane, parallel to the ground line. Okay. So then, in one-point perspective, the CV is the vanishing point. So the vanishing point is always on the horizon line. It's the rule. It's always on your horizon line because that's the point at which you are looking. So we get to decide where we want to put the vanishing point in one-point perspective. I'm placing it just in the center, which will emphasize equally the symmetry of this space. There are examples hold on a second. There's examples in here, I think, that sort of show you I thought, maybe not. Anyway, I can show you examples. There's examples that can show you, like, if you do it to the center, to the left, to the right, how that skews what you're seeing. Yeah.
So when it's 2-point, it's not the same point.
Yeah, don't worry about 2-point. We're going to go over 2-point too. So just all we're worried about right now is 1-point. Don't even think about 2-point. Okay, so this is going to be our vanishing point. So anywhere that the picture plane, this is like the technical thing, anywhere that the picture plane is coplanar with what we're cutting through on the section, we can measure at real scale. So if we think of the picture plane, here's our plan, we think of the picture plane slicing like a section. You guys know how to draw a section. So you know that on this section line, this is the true measured height, and this is the true measured length. So those are measuring lines, and we know that they're actually to the scale. So these will be, if our drawing was at 10 scale, these distances right here are also at 10 scale, and we can measure off of those. So I will just do a little, this is our measuring line over here. I won't get it in the mix of everything now. And this is our measuring line, going up into infinity. So the first thing that you would do to figure out the depth is to decide what you want to get, what you want the depth, what you want to place, right? So we're going to place this corner. So the easiest way to do that is to figure out if it has something that's on the picture plane, right? And it does right here. So I know that this point here, which is this point here, which is this point here is this. Those points are the same, right, in plan and in perspective. I'm trying to find that point. I know that if this is here and it's going into my vanishing point, if I'm looking, I'm connecting that. So I know that this point is going to be somewhere on this line. Mm-hmm. Right, so I can draw that line. Brooke, are you with me?
Yeah.
Okay. Maybe I'll explain this a little bit easier this time. So now, to find out where, on here, how far this depth is, from 1-point perspective, what we can do is simply measure and plan. So we're going to measure, we're 5 feet, 5, 10, about 12 feet in my little sketch. So I'm going to measure off 5, 10, 12, so it's about here. And you can do this because, well, you can just do this, just trust me. You can find out why if you want to read the whole thing. I can explain it if people are really confused. So, this line segment here is A. This line segment here is A. Those are the same distance, right? We measure the distance off the picture plane and then we place it onto the ground line. If this, let me not confuse you. Okay. Then, we didn't. So we had our, do you guys remember we had the two diagonal points, the left and right? Okay. To find out where where on this line is that actual point, we very conveniently just draw from the point that we measured to our diagonal point to the left. It's going to intersect that line. That's the point. This intersection is that point. Right there.
And the DPL and R are 12 feet from center, is that right?
They're the distance that we're standing away from the picture plane. So we decided we were 15 feet away from the picture plane.
Oh,
So
right,
they're
right.
the 15 feet that we're away from the picture plane. To figure out how high this is, right, how high this wall is at that point, we can go from, we know it's going to be on this line, so we just draw that line, and then we drop down perpendicular, and that is our wall.
Cool.
So if you had something extending, the only tricky thing is if you had something extending, if you were cutting through the picture plane, you had something extending further, then instead of measuring this direction, you would measure that direction. So if this was 4 feet this direction, then I would measure off the picture plane. I'd measure 4 feet here and make my line. Then I draw my line between where I measure to and the diagonal point or distance point, whichever way you want to call it. And I do my vertical, and now that's my wall. And it gets bigger, it goes beyond, it comes out towards me from the section.
I have a quick problem why you're drawing that second line, why you're not just measuring from the two original diagonals. So the green line.
Why I'm not measuring this?
Yeah. Like why
Because of foreshortening, right? So this is how long it actually is in plan, but when I put it into perspective, I no longer know how long it is anymore. So this is whereas this and this are still at 10 scale, this is at some scale that I don't know. So the thing that you can do is you can actually buy grids and things that are 1-point perspective grids and 2-point perspective grids, and you can draw over them and just sort of like, because the other way that you can do is like if you know that these are every 5 feet, and let's say there was another little tree here, you could tick off an even amount and just, guesstimate where things are as well. If something in 1-point perspective, if something were sitting here, if there were a tree sitting there, so it's not on the picture plane and it's not in line with anything that's on the picture plane, I just extend down to the picture plane.